Hey guys, Miss Miklos here with our final lecture of the semester. And good news, it's going to be a quick one because we're really doing exactly what we did in the previous lecture. This lecture is really about finding rational zeros, and that's kind of the title in the book on this section. And the directions it's going to ask us to do is find all the real zeros. And this actually makes our life easier because I know if I have imaginary answers, I can just throw them out and not worry about them at all. And everything else we're going to do in this same exact manner that we did in the previous lecture. Okay, so here is the only problem we're going to go through today. F of x equals x to the fourth minus 5x cubed plus 7x squared plus 3x minus 10. So the first thing we're going to find are our possible rational zeros. And remember, those are the factors of our constant divided by the factors of our leading coefficient. So in this case, things that multiply to be 10 would be 1 and 10, 2 and 5, and I know I need plus or minus. My leading coefficient here is 1, so I know that only factor would be 1, which gives me options of plus or minus 1, plus or minus 10, plus or minus 2, and plus or minus 5. So those are the options that we're going to use. Now, since this is to the fourth degree, I'm thinking we have a possibility of having 4 real zeros. However, I know that I might also have some imaginary answers which we don't care about. So what I'm going to do here, I'm going to set up synthetic division. 1, negative 5, 7, 3, and negative 10. And I'm going to go ahead and start. I'm going to start with 1 here. So I'm bringing down my 1. 1 times 1 is 1. When I add, I get negative 4. When I multiply, I get negative 4. 7 minus 4 is 3. 3 times 1 is 3. 3 plus 3 is 6. When I multiply by 1, I get 6, which is negative 4. And unfortunately, that did not help us out at all. So I'm going to go ahead, first space-wise, I'm going to erase all that and start over. The joys of solving using synthetic division here. So now I'm going to try negative 1. And I'm hoping this gives us a better result. 1 times negative 1 is negative 1. When I add, I get negative 6. Negative 6 times negative 1 is 6. When I add, I get 13. 13 times negative 1 is negative 13. When I add, I get negative 10. Negative 10 times negative 1 is 10. And we get 0, which is wonderful. And it makes me really happy because I just found that one of our zeros is x equals negative 1. Now, unfortunately, I know I'm not done yet because this polynomial drops 1 degree, so I know this is now x cubed. So we're going to have to use synthetic division again before we get it into something that is quadratic. Okay, so I'm taking that line and I'm going to use 2 and see if this works. So I'm bringing down my 1. 1 times 2 is 2, which is negative 4. Negative 4 times 2 is negative 8, which is 5. 5 times 2 is 10, so I get 0, which makes us happy. So we know our x values so far are negative 1 and 2. At this point, this function is quadratic, so I'm going to write x squared minus 4x plus 5 is equal to 0. And the first thing I would try and do is factor it, but I know there are no factors of 5 that add up to be negative 4. So my next option would probably be to complete the square, or I could also use quadratic formula. It doesn't matter. I just prefer this method. So I'm going to take my middle coefficient, which is negative 4, and divide it by 2, and then square it. So I'm going to add 4 to both sides, and all of a sudden, I am noticing a problem. My left side is going to factor into the quantity x minus 2 squared, but my right side is going to have a negative 1. And the reason why this is an issue is because I know eventually I'm going to have to square root both sides, and the square root of a negative value gives me imaginary answers. The directions said I only want real answers, so at this point, I don't care about doing anything else. And we know that there are only 2 answers that are real. In fact, if you went ahead and graphed this function in your graphing calculator, you would see that it only crosses the x-axis at -1 and at 2. Okay, so honestly, that's all we're doing. Very similar to what we did last lecture. So that is it. Have fun on your walkthrough.